Good morning, or actually good afternoon, everyone. Good morning over here. Welcome to selecting the correct Azure solution for your application. My name is Denny Cherry. Welcome over to my session. Killed the pop-up on my screen here. So give me a second here. I'll talk a little bit about myself for a few seconds, and then I'll get on to the information you guys actually care about listening to. So my name is Denny Cherry. I'm the CEO and principal consultant for Denny Cherry and Associates Consulting, based out of San Diego, California, where it's currently 6 a.m. I've written 8 or 9 books now on SQL Server, including Securing SQL Server, which is that blue one, as well as the SQL Server MVP Deep Dives, which is that, not orange one, yellow one there, with all the proceeds for that one going to Operation Smile. I've written dozens of magazine articles for various websites, including SQL Server Magazine, WinIT Pro, TechNet Magazine, MSN Magazine, as well as several other ones. I've been a Microsoft MVP for 14 years now, I think. I'm a Microsoft Certified Master, and I'm also a VMware V-Expert. All right, enough about me. Let's talk about the stuff you guys actually care about listening to. So today I want to talk about how to select the right kind of data solution for your application that you're going to be putting in Microsoft Azure. So Microsoft Azure has a variety of ways to store data and put data in the data platform solution. You can put SQL Server in a VM. You can use the SQL Database solution. You can use SQL Database Managed Instance. You can use Cosmos. You can use Synapse. There's probably a couple other ways as well, but I'm not going to cover those. These are the 5 that I want to focus on over the course of the next hour. So one of the things that I really like about Azure is it's incredibly wide. So you can store data in a variety of ways. You can do pretty much anything in Azure in a variety of ways. It's just a matter of how you actually want to do it to get the best use case for your application. So one of the things I want to focus on, obviously, is just the data piece of this. So I want to just focus on just this green box, because as you can see, there are lots of different ways to store data. That's one of the cool things about the Azure platform, is that you can pick and choose what the best way to do things in your specific environment are. And so a lot of these ways can be used interchangeably. A lot of these ways are going to work in some use cases and not work in others. And that's kind of what I want to focus on today, is what are the specific use cases for a specific application? Let me rephrase that. What are the use cases for a specific data storage technique so that you can get the best use case and best performance for your specific application? So let's start with SQL Server in a VM. So one of the biggest benefits that people get when they use SQL Server in a VM is that it gives you full control over that instance and full control over the operating system. So if you need specific patches to be installed on the server, or maybe you need specific software to be installed on the server, you have that ability because you control what's going to be installed and what's going to be there. So for example, if we're using full text search, and we need full text search to be able to process PDFs, we're not going to be able to do that in SQL Database or SQL MI, but because those DLLs aren't going to be installed on those platforms. Whereas with SQL Server in a VM, we can simply install those DLLs on the server, and we can register those DLLs in the registry, and then we can go and do whatever it is we want to do, because we have that functionality available to us. We also have the full ability to manage what patch version we're on. So if we have a specific patch that we want to be on, or a specific version of SQL Server that we need to be on, we can control that, because again, we control the VM. So for example, maybe we need to be on SQL Server 2016, the GDR, the final GDR patch, for example. We don't want to go any further past that. We can control what version of SQL Server we're using, because again, we control the VM. We control everything about that virtual machine. Because we're in virtual machines, we control the high availability and disaster recovery configuration for this VM. So we can control, hey, we need to spend the money and have an HA and a DR environment, or maybe it's an environment we don't need that for. So maybe we only need to spin up the database and not spin up a high availability solution for the platform. And maybe we don't need to spin up a DR solution for the platform, or maybe it doesn't need to be an instant failover situation like we'd have with SQLDB, where we can simply just fail over to another region. And so we go, hey, we only need a backup and a restore solution. So we just back up the database every day to a blob storage account, and then we just restore the database in the event that the server fails. And we're fine if the server is down for 6 or 8 hours. So we can save some money by deciding how we're going to actually, put this server in this position. So like I said, we can pick and choose the version of SQL Server that's going to be deployed to the server, to the system, because again, we control all of this. Same with the specific build of SQL Server, because again, we're going to control all of this. We have control over this entire environment. One of the great things about virtual machines over the PaaS options is we have complete control over when things are going to be happening in the environment. So if we need to do patching, for example, we control when those patches are going to be deployed. In Azure SQL DB, or in Managed Instance, or Cosmos, or any of the PaaS platforms, we don't have control over when things are going to patch. So things are going to patch at the convenience of Microsoft, and more importantly, they're going to patch when the Microsoft automated patching rolls through the system and does its thing. So we have no control over when those things are going to patch or when those things are going to fail over because of that patching. Whereas in a virtual machine, we are going to have complete control over when that happens. Because we install those patches, so we have the ability to schedule when we're going to roll those things out. We have extremely fine-grained control of the firewall rules. We control exactly what's going to be connecting to our SQL database instance, whereas what doesn't. We have much less control over that in the PaaS platforms. We can only open up port 1433, and we can only control port 1433 in the PaaS platforms for MI and for SQL Database. Obviously, it's other ports for Cosmos and the other options. Whereas on the SQL VMs, we can control everything else. So if we need to grant access to something else, for example, we have the ability to do that. One of the great things about SQL VMs is we can assign basically as much storage to the VM as we need. Our storage capacity is only limited by the size of the virtual machine. So we can apply dozens of terabytes of storage to a VM if we need to. Whereas with Azure SQL DB or Cosmos or MI, we're much more limited in the amount of space that we can assign to an environment just based on the technology that's behind this, especially when we look at Azure SQL DB or managed instance that don't necessarily have Hyperscale, or we need to enable Hyperscale to be able to put a large amount of data in that database. Whereas with the VM, we can just assign space and our database will just grow to fill it as needed. We can also, in a VM, assign different speed of storage based on the needs for VM. So, perfect example of this is one of our customers has a VM that's up in Azure, and they've got Ultra disks for the transaction logs, and they've got standard premium SSD for the database file. And this works very well for them, but this option wouldn't be available in SQLDB or MI or any of the other platforms because you don't have this sort of control over what kind of storage you're going to be using. So they're able to mix and match what kinds of storage they need based on the needs of the application, which is a great selling feature for the VMs. So SQL can be used in a VM for either an OLTP system or a decision support system or data warehouse. It's up to you as to what you're going to put on there, because again, it's just a virtual machine. So you can use it for pretty much anything you want. The databases can be configured across multiple disk volumes, and that'll give you the maximum amount of I/O possible within that virtual machine. So one of the things I do want to note is that virtual machines are limited in how much I/O they're going to be able to have up in Azure. So you're going to be limited based on the size of the VM as to how much I/O you can actually push through down to the disk. And it's probably going to be less I/O than the disks can actually support. So say you've got a VM and it will support having, say, 10 disks assigned to it, so that's 50,000 I/O, but the virtual machine itself may only support 40,000 I/O. So you got to be very careful as to that you're picking a virtual machine size that's going to support the amount of I/O that you need to actually support the platform that you're working with. There are websites out there, and if you dig through Microsoft Docs, it will actually tell you how much I/O you can have for each specific size of VM. And so these are going to be some very important numbers, especially as you're getting towards the top end of them, to make sure that you're not overloading the VM and trying to push more I/O than the VM can actually support. So because this is just a VM, everything you expect from SQL Server to work just kind of works. Because again, it's just a virtual machine. So you have the full range of features that are going to work within this platform. So if you've got a really monolithic database, that can be created without issues in this platform, because again, it's just a VM. You'll notice I've said that a lot at this point, that it's just a VM, and that's because it is. You can do pretty much anything you need with it. We've all been working with VMs for a long time, because that's what we've been having on-prem before we actually went up into the cloud. Now, from a billing perspective, we have this thing called reserved instances, and you'll see me mention this for pretty much everything I'm talking about here over the course of the next hour. Sorry, let me close my window here. I live right next to a Marine base, and lots of people have very fancy, loud cars. Give me 1 second. There we go. I was hoping to get away without closing that because I like the fresh air, but hey, you can't always get what you want. So what reserved instances are is where you basically commit to using a resource in Microsoft or in Azure for a extended period of time, either 1 year or 3 years. And because you commit to that 1 year or 3 year time frame, Microsoft gives you a discount on the price. So you can get something like 20 to 30% off the retail price of a box by simply saying that you're going to be using this for a long period of time. So if you're going to have a VM that's up in Azure for 1 to 3 years or more, you'll be well off to actually tell Microsoft, hey, yes, we're going to use this VM at this size for an extended period of time. Give me the price discount that's associated with that. And that's going to be the reserved instance price. Now, reserved instance pricing is not available for all VM sizes, but it's available for most VM sizes. So it's worth taking a look in the portal if you can get that reserved pricing. You can also look at the pricing page at azure.microsoft.com to see if the reserved instance pricing is available for that VM size. And again, that'll save you 20 to 30%. So it's definitely worth looking at that pricing to see if you can cut that pricing down. So let's talk about Azure SQL, because that's the other big way that people tend to store databases in Azure. So there are 4 flavors of Azure SQL DB. There's Azure SQL, so that's the original offering. That's the most traditional way SQL Server based version of Azure SQL that we think of, where it's SQL Server databases in the cloud. Our other options are Azure Database for MySQL, Azure Database for Postgres, and Azure Database for MariaDB. So these are all the open source offerings, and these are based on the open source offerings that we're used to based on with those names. So if you think of the Azure Database for MySQL, it's going to be a MySQL instance in the cloud. Same with Postgres, same with MariaDB. So the biggest difference between those three and the traditional Azure SQL that we're used to is traditional Azure SQL is database in the cloud. Azure Database for MySQL, Postgres, or Maria, those are all more like managed instance, whereas those are an instance in the cloud. So, for example, with Azure Database for MySQL, we use that to host the database for our website. So our website is WordPress, so obviously it requires a MySQL database on the back end. So because of that, we use the Azure Database for MySQL offering, and that just puts our database up in our case, US Central, and allows us to connect to that and use it as a traditional MySQL database. We can create separate databases within that, and we just have the instance that we pay for as part of our Azure Database for MySQL offering. So, like I said, Azure SQL is going to be a cloud-hosted database, and it's a completely cloud-hosted platform. So it's a very customized platform. It's very similar to SQL Server. It's not completely like SQL Server, especially when you look at how the back end of it is actually working. The databases can be configured as a single database or within an elastic pool for billing and performance purposes. So the big difference there is going to be if you want your performance to be isolated to that database so that the performance of that database does not affect any other database, you would go with the single database offering, not the elastic pool offering. The upside to elastic pools is you throw lots of databases in the elastic pool, and then from a pricing perspective, you only pay for that elastic pool. So maybe you've got 4 VCores. You can either send them to a single database, or you can assign those 4 VCores to an elastic pool and put a bunch of databases in that elastic pool. Now, the downside to that is that once you put databases in the elastic pool can be affected by a single database. So if one database runs away and takes all the performance of that pool, or takes all the CPU load of that pool, that's going to impact all the other databases in that elastic pool. So there's some give and take there that you've got to understand. Now, you can tell the elastic pool, hey, make sure this database can only use so much percentage of the elastic pool. There are some things you can do to limit how much damage one database can do to the entire pool. But do keep in mind, it is possible to have a single database take all the load of an elastic pool and basically kill the performance of the elastic pool. So applications can be migrated directly from on-prem to Azure SQL DB. So you can't just pick up a database and move it directly up into SQL DB. However, the most successful migrations are going to involve application redesign. Applications typically don't perform as well in SQL DB if you just pick them up and move them. And that's because we need to think about things like scale out and performance and how we are going to work in this constrained environment within SQL DB. So the most successful applications are going to be the ones that scale horizontally across the application tier. So this makes me think of, need to drink some water. So this makes me think of a payroll company that I work with here in the US. They're one of the larger payroll companies. And they use Azure SQL DB in the back end. Now they have about 30 or 40,000 clients that they support. So each one of their clients has an Azure SQL database on the back end. So obviously the clients don't know how any of this works. The clients just know that they can run timesheets and they can run payroll, and that's all that matters. But on the back end, each client has an Azure SQL database, and that way they can scale effectively limitlessly as they add more customers into their environment. So for every customer that signs up, they simply get a new database so they can continue to scale their application. So it doesn't matter that, most of their databases are relatively small and only are single VCore databases, or even actually now in elastic pools that are, just a few VCores per elastic pool. They simply can continue to add more elastic pools and continue to add more databases and just scale that system out. If they just had one giant database, they would have hit the top end of the configuration tier a long time ago, and they wouldn't have been able to grow that database anymore because they wouldn't be able to add more vCores to that database. So we get really good performance by scaling horizontally across the application tier, or across the database tier rather, and then we effectively get limitless scale across our application. Microsoft has a huge number of resources available to us, and we can just simply add more databases to it, and we can get the scale that we need. So when we're in SQLDB, especially if we're in the single database performance model, not the elastic pool performance model, individual databases are scaled from a performance perspective from the other databases in the application tier, or in the database tier. So if we've got 5 databases, we can pick and choose how many vCores are assigned to each individual database. So, so we've got our 5 databases, they've all got 2 vCores. If we see a performance spike on one database, we can go, all right, cool, let's give that specific database 4 vCores or 8 vCores and give that database more ability to run things faster, more cores to run things faster. With elastic pools, we can do effectively the same thing, but we do it at the pool level, not at the database level. That elastic pool is going to be a group of databases, which are all going to be sharing resources. So as we scale up the entire pool, and that scales up all the databases in that pool. So it gives all the databases access to more resources. So for example, if we have an elastic pool at 4 vCores, and we see that elastic pool is starting to hit 80, 90, 99% CPU utilization, we can simply go, all right, cool, let's add more vCores to the pool. We take that elastic pool from a 4 vCore pool to, say, an 8 vCore pool, and now suddenly we've got more processing power for that application to work on. Now, SQL databases, I've talked a lot about vCores, are also available in what we call the DTU pricing model. That's the traditional pricing model that was available before vCores came out. We don't talk too much about DTU anymore because you can't actually build new databases in the DTU model. You need to switch over to the VCore model at this point. So the VCore model is available actually in 2 different models, either Gen 4 or Gen 5. I don't recommend Gen 4 anymore for new deployments because it's going to be going away at some point. It's only going to be for legacy deployments at this point, and we're going to be putting everything in Gen 5. And Gen 5 is going to be threaded cores, much like most of the VM infrastructures are. We also have the FSV2 series of VMs, and we have the M series of VMs as well. These are all different models that can be used behind your Azure SQL DB database. I'm going to talk a little bit about what all of them are. So we'll talk about the Gen 4 real fast. With Gen 4, you're going to be limited to 24 cores per database or elastic pool. So whenever I talk about how many cores you're limited to, that's either going to be per database or per elastic pool. With Gen 5, much higher limits. So Gen 4, again, we're limited to 24 cores. Gen 5, we're limited to 80 cores, and that's going to give us up to 396 gig of RAM. So the sliding scale for cores and RAM are not independent. They do go together. So if you've got 80 cores, you can have 396 gig of RAM. If you've got, say, 72 cores, it's going to be a smaller percentage of RAM. So it's going to go down, they're going to go down evenly as they go down, but they are going to go down together. You're not going to be able to pick and choose them independently. So Gen 5 cores are going to be based on a variety of CPUs. You don't get to pick which CPU you have. You're just kind of stuck with the ones that you land on. So these are either going to be the Intel E5 2673s, which are going to be your Broadwell processors, or they're going to be on your Skylake processors, or you're going to be on Cascade Lake processors. So it just kind of depends on which ones you happen to land on as you're running your databases. So Hyperscale is available, allowing you to have effectively unlimited storage in your database. This is a relatively new technology that's available, and it allows you to go beyond the 4 terabyte limit that you have with a traditional Azure SQL DB database. There is an additional cost to running in Hyperscale mode, but it does allow you to put as much data as you need into the database. So Azure SQL Databases, they are pretty much core to the Azure environment, so they're available in all the Azure regions when it comes to the Gen 5 database. So one of the cool things about Azure SQL DB is it supports this concept of serverless. So what we mean by serverless is, obviously there are still servers in the background. This is a horribly named feature, but I don't work for Microsoft, so I can say that. So what serverless means is it gives you the ability to auto-scale your database, and it also gives you the ability to auto-pause your database if the database isn't being used during certain times. So say you've got a database that is only used from 6 a.m. to 6 p.m. during the business day, Monday through Friday. It's not used in the evenings. It's not used on the weekends. So with serverless, if we turn serverless on, it'll actually pause that database from about 7 p.m. until your first user starts using it the next morning. So the really nice thing about paused databases is you don't pay for the compute. You only pay for the storage. So if you think about it, if you only use the database for half of the day during the business days, you don't use it on the weekends, you're only actually using the database for about 40% of the time. So why pay for the compute for the entire time when you can use it for just that tiny little bit of time? So this is the idea behind serverless. Now, the other great thing about serverless is this auto-scale functionality. So when you configure a SQL DB for serverless, you'd say a minimum number of VCores that you want supported and a maximum number of VCores you want supported. And as the server is used, it will auto-scale between the minimum and the maximum and all the values in between. So say we set a minimum of 2 and a maximum of 20. When the database spins up, it'll use 2 VCores. As more load gets put on the database, it will scale up slowly from 2 VCores all the way up to 20 VCores, because that's what we set for the upper limit. As the load scales down, it'll scale down from 20 VCores back down to 2. And we only pay for the compute we use. So we only pay for the number of VCores that are being used by the system at any one time. So it's a really great way to get that cost reduction while still getting the performance we need. The other big advantage to serverless is when it's scaling between vCPU sizes, it's effectively doing hot add and hot remove. So it scales without failing over. In a traditional SQL DB configuration, when we scale from one size to another, there's going to be a failover operation that happens. So all our users are going to be disconnected and they're going to have to reconnect. So they may see errors in the application. With serverless, we're not going to see that. Now, if you're running a database 24 hours a day, 7 days a week, serverless is going to be more expensive than a traditional SQL DB. And that's because serverless does cost a little bit more per hour than a traditional database does. So that's going to be something to keep in mind if you're in a database that needs to stay online all the time. Serverless probably isn't going to be for you because it is going to end up being more expensive than the same size vCPU, unless you really need that auto-scale functionality. So that FSV2 Series VM, or Series SQL Database, that's going to be limited to 72 cores and 136 gigs of RAM. It's going to be built on the Skylake processors. It's going to be available for Hyperscale as well. It's also going to be available in a lot of the Azure regions, but not all of them. You see I've got a decent chunk of Azure regions listed there, but that is clearly not all the regions that are available. We do support serverless as well for the FSV2 Series VMs. With the M Series VMs, these are some pretty beefy boxes. So we can now go to 128 cores and 3.7 terabytes of RAM. So that is obviously a lot higher than any of the other offerings that we've looked at so far as how big these Azure SQL DB databases can go. Again, we're built on a couple of different CPU options, the either Haswell or Cascade-like processors. But we can throw an awful lot of cores behind this. We can go with Hyperscale. Now, the downside to these M Series VMs is these are only going to be available in East US, West US, Northern Europe, or Western Europe. That is it. So my guess is that a big customer needed these in 2 of these locations, and the other 2 of the locations are simply the paired regions. So I would assume that they either needed them in East US or West US, and Northern Europe or Western Europe, and then obviously make sure to put them in the paired regions as well to make sure they were going to work. I assume these are going to scale out to all the other regions. I don't know that for sure. That's just my guess. Microsoft does tend to scale things out eventually to everywhere. It just takes time to buy things to put in lots of places. Again, we do support serverless on these M Series VMs, so we can get a lot of for these and some decent scale for them as well. Now, these Azure SQL DB databases are perfect for OLTP databases. We don't typically want to put data warehouses in SQL DB unless they're going to be relatively small data warehouses. Data warehouses will typically perform better in another solution other than Azure SQL DB unless they're relatively small. So a terabyte or 2, we can put those in Azure SQL DB. Once we go bigger than that, it might make sense to look at one of the other options. So your best use case is going to involve a scale-out configuration of the database tier. So where you add more databases as the business continues to grow, and if you can federate the databases or scale those databases out across the entire environment, and simply add more and more databases as you add more customers. So if you are in a business-to-business environment where you're selling your software to another business, it might make sense to have one database per business, or per one of your customers, because that way you can get the best performance and the best scale for your application. If not, you maybe want to have one database per a few customers or something like that, depending on what your application is and how it does and how it stores data. Now, one thing I don't have on the slides here is reserved instances are available for Azure SQL DB, but the reserved instances are not available for serverless. And that's because you don't have the server up all the time, so having a reserved instance wouldn't necessarily work. But you can have reserved instances for your Azure SQL DB databases as long as you're in the V5 mode, the VCore mode. Reserved instances are not available if you're in the DTU pricing model. So your open source databases, like I mentioned earlier, these are going to be more like managed instance than SQL DB. That's because these are going to be a instance as a service offering, not a database as a service offering. But once they're spun up, you're just like you're in a traditional VM environment for these instances. So, like I said, we're using the Azure database for MySQL offering, and From a usage perspective, it's just like connecting to MySQL installed on a VM or MySQL installed on-prem. The same is true for Postgres, the same is true for MariaDB. It's all exactly the same thing as if you were running your on-prem database or a database in a VM. So let's talk a little bit about managed instance. This is very near and dear to my heart, as I've spun several of these up in the last couple of weeks for one of our clients. So managed instance is SQL Server instance in the cloud. So different thinking from Azure SQL DB, which is a database in the cloud, whereas this is going to be that full instance. So this is going to solve a lot of the issues that come from running databases in Azure SQL DB, and it's going to solve a lot of the problems of not being able to run specific software in SQL DB. Specific problems that are going to get solved: cross-database queries, having access to the MSDB database and the SQL Server agent, and having the ability to have linked servers. So you get all of these in managed instance, which you did not have in Azure SQL DB. So that's the upsides. Let's look at the downsides. So biggest downside, you are limited to 100 databases per managed instance. So if you need to be able to put 1,000 databases on a server or even 101 databases on a server, that's going to be a problem too. You're going to need to do an application redesign to be able to work within the limit of having only 100 databases per MI available to you. You are limited to 4 terabytes per database, and you are limited to a total of 8 terabytes per managed instance. And there's no way around this right now, so you are stuck at these size limits. So if you've got 10 databases, each at a 1 terabyte of size, those are not going to fit on a single MI. You're going to have 2 MIs to host those databases. So you're going to need to be, your application is going to need to be able to work within those limitations. So MI is going to be great for OLTP databases that can't be scaled out in SQL DB, or applications that need a feature that's not supported by Azure SQL DB. So like I mentioned, I've been spinning up a couple of MIs specifically for a client over the last couple of weeks. They're actually planning on doing their migration to Azure later tonight. So I'm going to be taking a nap after my presentation today because I have to be able to stay up late tonight to actually do their migration over to MI. So they've got a requirement for cross-database queries, they need link servers, and they need SQL agents. So they actually need all the features of MI to be able to run their application. So they're forklifting from an on-prem SQL Server, obviously, up to MI. Their long-term goal is to get out of MI and be able to get into traditional SQL DB, but that's going to take a lot more redesign than they want to put into the application for this migration. They just want to do this migration so they can stop paying their old hosting provider and only pay for Azure. So let's talk a little bit about Cosmos. So Cosmos is a really cool, really interesting platform. It's an auto-scale platform, so it will scale up and scale down based on your needs and based on how you're using the platform. So Cosmos has several different engines and APIs within the actual platform itself. So it's not just a single database platform, kind of like SQL Server is. It's more of an environment, and it's got lots of different database engines all running within it, and lots of different ways for you to talk to that database engine. So Cosmos can be configured from within multiple regions. So you can have a single database across multiple regions. So you can have that database in, say, Northern Europe, Southeast Asia, and US West. And you can actually write to all those various copies of the database. So you can have a multi-master write situation, which we don't have in SQL Server. So data is partitioned within the Cosmos platform for maximum performance. And if you don't partition your data, you're not going to get that high level of performance you're expecting out of the platform. So Cosmos has a lot of APIs available to it. including Gremlin, Cassandra. It's got a SQL API, it's got a Mongo API, and it's got a traditional table API. So you can talk to it through any of those APIs, just like it was those platforms. So I'm going to talk about the Mongo one specifically, because that's the one I've got experience with, or the most experience with. So we had a customer, they were using MongoDB on-prem, and they wanted to start using Cosmos. And so they started looking at the Mongo API, and they were rather impressed because they literally just told their app, changed the connection string in their app and told their app, hey, just talk to this database now instead. And it just accepted all the Mongo commands that their app was sending. And it was able to just work with Cosmos using that Mongo API without having to make any changes to their application. So they were rather impressed as they did that swing over. So lots of ways to talk to this, just like it was lots of different kinds of databases. That's the whole point of this, or one of the points of this, is it's just supposed to work and let you scale over and move things over to it. Now, there's no limits on how much data you can store in Cosmos. You have an infinite amount of data you can put into the platform. You just keep shoving data into it, and it keep accepting the data. However much data you shove into it, that's what you pay for. So as far as the compute side of things, your billing is going to be priced based on what's called an RU. The more data that you return, the more RUs you're going to be consuming. So the idea behind Cosmos is you want tiny little bites of the data. You only want to be pulling out singleton rows out of the application or out of the data store. If you pull out a huge data set of 100,000 rows, that's going to be very expensive. So when Cosmos first came out, one of the running jokes about Cosmos was we can never quote how much it was going to cost. It's going to cost you somewhere between, I think it's $400 at the low end, and all of your money at the high end. And the reason for that was it depends on how badly your developers write their database queries against Cosmos. If they write them very well, you're going to be at the low end of the cost spectrum. If they write their queries very poorly, you're going to be at the high end of the cost spectrum, and the high end being all of your money. So that's going to be something to keep in mind. You want to write your queries very, very carefully to return only tiny little bits of data. If you're planning on using this as a reporting system and running large reports against Cosmos, that's not going to be what you want to do. You're going to want to put that data in something else, either SQLDB or SQL Database or SQL Data Warehouse, so that you can actually run your reports against there and only run your operational systems, your OLTP system, against Cosmos. So, like I said, large data sets, very expensive. Now, you can reduce your cost of your Cosmos environment by using reserved instances. So with a reserved instance, in this case, you go, hey, I want to pre-buy X number of RUs. So say you've got a Cosmos application that's configured for 100 RUs. So you go, hey, I'm going to commit to 100 RUs for the next 3 years. It's going to drop your price by 20 to 30%. So RIs are a very good way of helping reduce your cost, again, against Cosmos, against SQLDB, against VMs. So Cosmos is going to be ideal for logging applications where you're just writing data constantly and never reading it. So it's also great for applications with consistent query workloads of very small queries. Again, you don't want to be running large queries against Cosmos because it's going to be very expensive for you to do that. So let's talk about Synapse, formerly known as Azure SQL DB, formerly known as APS, formerly known as SQLDW. It's got lots of names. So this is Microsoft's large MVP database platform. So this is going to give you the ability to scale out your workload across multiple boxes on the back end. How many boxes? That's going to depend on how much you want to pay. So this is a great solution for data warehouses, as long as those data warehouses are at least 1 or 2 terabytes in size. So Megan Longoria on our team, she says that you want to start looking at Synapse once you start getting towards about 5 terabytes, she recommends staying in Azure SQL DB until you are at about 5 terabytes, because you're not going to see any of the real benefits of being in Synapse until you hit 5 terabytes, and it's just going to be expensive for you at that point. So one of the things to keep in mind about Synapse is it does require a little bit different database design than a traditional SQL database or SQLDB or SQL VM database is going to. And that's because you need to correctly scale the data that you're putting in the system across all the partitions to get the best performance out of it. And you want to understand the data you're putting into the system so that you're sharding that data across all the databases on the back end to get the best performance out of the platform. You don't want data from one instance to be joined to data from another instance, because then you're going to have all sorts of data movement that has to happen between the backend databases, and it's going to be very expensive. And you're going to get a lot of what we call these data shuffle operations, as the data has to be moved around within the backend to actually join this data together. Now, there are some limits in Synapse. Specifically, you are limited to how many concurrent queries you can run. The size of your SQL data warehouse, the size of your Synapse database will determine how many concurrent queries you can have. So because there are limits on the number of concurrent queries that you can have, that makes this not a good viable object for your OLTP workloads. So I was talking to somebody on Facebook a while back now, and they were working with a supposed data professional organization as a consulting firm, and they had designed this nice application to run on Synapse. The problem was this application was supposed to be backing an API that was going to be called tens of thousands of times a minute by their customers. So everything worked great in development. As soon as they started doing load testing and QA, the entire process fell over, and their API calls went from milliseconds to multiple seconds because of this concurrent workload problem. So she put on Facebook, hey, this is the issue we're seeing. We don't know why we're seeing it. We're in SQL Data Warehouse, and the whole reason that the consultant had pitched SQL Data Warehouse to them was because of the scale-out functionality that SQL Data Warehouse had. So I'm like, well, there's your problem. You're in SQL Data Warehouse. I'm like, script the database out, put it in SQL DB, scale it to the largest size, and you'll be good to go until you can do some redesign, and you'll get over the hump of getting this thing out the door. So they did that, and the database ended up working in SQL DB. It's like, okay, cool. That at least solves my problem of performance being good enough to get this thing working, and it was. So with Synapse, we scale across multiple nodes on the back end. So this is the whole way Synapse works. It effectively just spins up a bunch of VMs on the background, and each of those VMs gets a small database and gets a portion of the data that you're putting in the platform. So as we scale quickly, we can scale quickly and easily, but as we scale, it'll simply detach to those databases and attach them to the new instance as it needs to. So if we scale down to a smaller database, or to a smaller Synapse environment, we will just simply detach databases from nodes and attach them to the inner nodes that we are keeping, and we'll just get rid of the empty nodes. As we scale wider, it'll simply, again, detach the databases from those nodes and just attach them to the now empty nodes, and that'll give us more scale within the environment. So our storage is going to be allocated in Synapse in 1 terabyte chunks. And again, that terabyte is just going to be shared across all the databases in the environment. So as we load data in, it'll just grow as we need to by allocating these 1 terabyte chunks of data. Unlike our SQL database environments, storage is effectively unlimited in the Synapse platform. So we can put a huge amount of data into these databases. So hundreds of terabytes, petabytes, not really going to be a big deal for Synapse. It will be able to take and process all this massive amount of data. Reserved instances are available for Synapse, so you can, again, reduce your price on those Synapse environments. So let's talk a little bit about Hadoop. So the Hadoop offering is going to be provided through the HD Insight service within Azure SQL, or within Azure. So it's going to provide a variety of engines to you. Hadoop, Spark, machine learning services, Kafka, HBase, Storm. There are additional engines that you can install, but those 6 are going to be the only ones that come with support and come with an SLA, a service level agreement. So any additional engines that you install on your Hadoop offering are not going to be supported by Microsoft, and they're not going to have an SLA because Microsoft doesn't provide the support for them. But you can put pretty much any engine you want in the environment. So these are going to be perfect for scale workloads where you need to do data processing over the workloads. So there's lots of use cases where people have spun up a Hadoop cluster, loaded a huge amount of data into it, done processing on it, and then deleted the Hadoop cluster when they were done. So those are the kinds of workloads that you can throw at this, where obviously you keep the Hadoop cluster up and just keep throwing data into it and process that data as you need to. So the ideal use case, like I said, is kind of just the one I described. Create a cluster, load data, process data, delete the cluster. So if you're a big fantasy football fan, for example, you might want to take all your fantasy football stats, create a Hadoop cluster, load all of that data into it, process that data, figure out what your team is going to be based on that, and then delete the cluster. That will give you a significant advantage over the other people that are in your fantasy football league, because they're probably not going to be doing that sort of thing, and they're probably going to be picking and choosing things at random based on, the thinking and the stuff that they've done. So I know I've covered an awful lot of material. Are there any questions? So feel free to hit the raise hand option and we'll unmute you, or just type a question that you have into the chat. So I do know I've covered an awful lot of stuff. There's an awful lot of really cool ways to store data in the Azure SQL environment. So it's just a matter of, finding the right one for your solution, and so you can get the best performance out of the solution and out of the platform that you're looking for. I don't see any questions, and I don't see anything in the chat, so I'm going to give it another minute here in case anybody throws anything in there. And well, since I don't see any, I thank you all very much for coming. I do appreciate it. Hopefully next year I'll be able to actually come out in person. I've been out to SQLDay a couple of times, and I had a great time when I was out there back in the first couple of years. It was up and running, and I hope that I can come back out in the future and come visit you guys in person instead of just looking at avatars on the screen. If you need to get in touch with me, feel free to email me. Contact info is up there on the screen. If you just hit info@dcac.com, that'll go to me as well as a couple of other people, and one of us will be able to get back to you as quick as we can. But I'll thank you very much for having me. I appreciate it, and I hope you enjoyed the SQLDay conference, which I believe is over, if I remember looking at the schedule correctly. Thank you all for coming, and have a great rest of your week, or rest of your day rather. The week is over. No, week's not over. It's Wednesday. Have a great rest of your week.